to this computer. And now I'm going to go ahead and share my Microsoft whiteboard. So I'm sharing it right now. I'm going to make it big and let's begin. So, yes. On the computer, give me 1 second. Okay. All right, guys. And I don't like that whiteboard because it's the whiteboard from Teams, and I don't really like the whiteboard from Teams. So even though it should be similar to the Microsoft whiteboard. So I'm gonna go ahead and do that. That's better. Stop this chair. Share with the Microsoft whiteboard. Share sound. There we go. And now we're here. There's where it is. Okay. So here's what I want to go ahead and discuss today, guys. I want to go ahead and discuss some concepts you already know on mean, median, and mode. And I'm going to try to be as thorough as I think I can be with you guys. So let's see what we can generate. So does anybody know what the mean is? You remember? Yes. So you add up all the numbers and do what? Divide it by the amount of numbers. So I don't know, let me throw some numbers here. So you have these numbers 1, 2, and 3. What would be the mean? It'd be what? 1 plus 2 plus 3 divided by what? What do you divide that by? 3. So that's 6 divided by 3. That's 2. Now, that's it. That's all a mean is. We have another word for this. It's called the arithmetic mean. Some people say this is the average. Some people say this is the average. The problem with the average is when you hear the word average, you should be asking, when you hear this word average, you should be asking, are you talking about the mean or the median? That's what you should say. That's a question you should ask. Every time somebody throws an average out, they don't say whether it's a mean or median. You need to ask them, hey, which one is it? Now, what's interesting about this is that obviously they can't leave it that simple. So let's introduce the symbology here. The book makes a distinction between a population mean and a sample mean. And if you recall, a sample is a subset of a population, while a population is all the responses or counts or measurements that we're interested in, if you remember clearly. And they say the following, they use this letter here, this Greek letter, which is mu, and they say it must equal the sum of x divided by capital N. And x bar is the sum of x divided by lowercase n. And even though that looks weird, it's not. X will stand for the amount of elements you have in your set, the amount of numbers we have there. So if we have some x is one, let's say I'll show you an example, but it's just the numbers that we have. We're going to add them up. And then the n will be how many numbers we have. It's going to be very clear for you guys to see this right now. So let's say you have population. So here's a population of numbers, and it doesn't matter. 1, 2, 3, 4, 5. And I ask you to find the mean for this population. So the mean for this is going to equal the sum of x divided by capital N. Well, just briefly, what's n going to be here? How many numbers do I have? 5. And what's the sum of x? 1 plus, 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 plus. So 5 plus 4 is 9, 9 plus 3 is 12, 12 plus 2 is 14, plus 1 is 15. So now you have everything. To figure out the population mean. So what's the mean? 3.
Good morning, gladiators. Please excuse this interruption. Teachers, at this time, if you could please release those students scheduled to take the Algebra 1 EOC exam. Again, teachers, at this time, the students scheduled to take the Algebra 1 EOC exam. Also, students, if you have not yet reported to take the Algebra 1 exam and you missed any day, please go ahead and report today to your testing location. Ms. Nino sent an email to teachers of any students who were missing the exam and where they should report. Good luck, gladiators.
Okay, so now I gave you some numbers there. And instead, it comes from a sample. And I'll ask you to find the mean. So the mean will be what? Well, I know I said this quickly, but this stands for x bar. It has an x with a little bar over it. So I would say the mean here is x bar equals the sum of x divided by lowercase n. Lowercase n is going to be the same as uppercase n. It's just we just make a distinction in terms of notation between the sample and the population. So what is lowercase n going to equal to here? How many numbers do I have? 5. And the sum of x is what? 6 plus 7 plus 8 plus 9 plus 10. So what does that come out to? Does it come out to 40? 40 it is. So 40 divided by 5 equals 8. So your sample mean, your x bar, is going to be 8. So this is pretty easy. This is pretty easy. So far, so good, right? So that's pretty much basic mean, median, mean. Now we're gonna go to our median. Any questions on mean? Okay. So I'm gonna use my ruler right here. Make a division. And so let's talk about median. Of course, I couldn't go all the way because that would have been awesome. That's close enough. Okay, so median is the next concept I want to talk to you about. Let me see if I can drag this somewhere. There we go. So let's talk about median. Median means your middle number. Now, something I didn't make pretty clear is that the mean and the median are both measures of central tendency. I'm gonna let me make it look pretty. Well, let's see if I can squeeze it, of course, because that's awesome. Measure of central tendency. What do I mean by measure of central tendency? Well, when you have data, it kind of groups up somewhere. And usually it groups up around the center. So the mean has the advantage of taking all numbers into consideration. And as you will see, the median doesn't do that. The median doesn't really take all numbers into consideration. But it is trying to measure the center because it's trying to pick the middle number. So what do you do to get the median? Number one is you put the numbers in order. And number two, you pick the middle number. If it's odd, you just pick the middle number. If it's even, you find the midpoint or mean of the middle two. So let's do an example or two. Say you have 2, 20, 17, 7, 8, 9, 21. Are these numbers in order? No. Let's find a median. What's the first thing you must do to find a median? Put them in order. So let's put them in order. 2, right? 7, 8, 9. What else? 17, 20, 21. And so now some of you might say, okay, let's find the middle number. Cross this out, cross this out. Cross this out, cross this out. Cross this out, cross this out. And so therefore, your median will be what number? 9. let's just say little, let's say this is a sample. This is a sample of numbers. Little n was 7 here. Now, before I continue, I want to just go ahead and ask you, number 9, what place was number 9 in? What number? Was it the first number, second number? What was it? It was the 4th number. So this was the 4th number when you put it in order from least to greatest. Now, let me give you another set of numbers. I'm gonna put it in order. It's gonna be a sample. So here's another example. 2, 7, 8, 9, 17, 20, 21, 21, 23. How many numbers do I have here now? How many numbers do I have there on the board right now? 9. So I purposely made it an odd amount. Now let's go ahead and begin crossing out. This one and this one. 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 And what's going to be my median? 17. And what number was this one? The 5th. So why am I going through that trouble? Is I'm going to ask you, hey, what's n here? What's the size of my sample there? How many numbers do I have? 9. What's 9 plus 1? Divided by 2? So this little rule here tells you that the median should be the 5th number. Let's try over here. What was n on the previous example for the 7 numbers? 7 plus 1 divided by 2 is 8 divided by 2, which is the 4th number. This is a quick way for you not having to cross out numbers. Because if you have a little bit of numbers, crossing out is fine. But if I gave you, I don't know, 73 numbers. So if I ask you, hey, there are 73 numbers in order. I could say in ascending order, means from least to greatest. Obviously, we think of it from left to right. Hey, I swallow the whole word there. There are 73 numbers in ascending order. Which number, I would say, which place is the median? So we don't care about the actual number. We want to know in what spot it is. So what are you supposed to do? You say, oh, well, that's easy. And here's 73. So since it's odd, 73 plus 1, we make it even, is 74 and divide it by 2. What's 74 divided by 2? The 37th number. The 37th number is your median. That would be the middle number. Fair enough? So again, these are little rules that are nice to know. Now I'm going to continue here. So let's talk about another sample here. So here's another example. And this sample is going to be 2, 7, 8, 9. I'm gonna put it out of order. 7, 2, 2, 3, 9, 10. Are those numbers in order? No. So the first thing we do is we put it in order. So you have 2, 2, 3, 7, 9, 10. Now we want to find the median. What is the median going to be? Well, we start crossing out. And here's our problem. We have the middle two. So the median will be that middle part. Now before we had the middle part exactly at the middle. See, the median splits the data in half. The median splits the data in half. Gives you two perfect sides. So what we do is we say, okay, let's take 3, we add 7 and divide it by 2. That's 10 divided by 2. So it will be equal to 5. So the median here is a number that's not even in the data set, but that's okay. It's going to be 5. And here would have been 6. So that's what it is. Let me make that 6 better. Let's do another set of numbers here. Just do the same set of numbers. So here we go. Let's find a median. So we're left with the middle two. Once again, in this case, n was equal to 8. N was equal to 8. So we take 7 plus 9 and divide that by 2. That's 16 divided by 2, which is 8. So the median here is 8. Now, maybe we should come up with a rule for evens as well. Now, what numbers that I add up together for this example? I added up the fourth number and the fifth number, right? And divided by 2, right? So now, what is n here? What's 8 divided by 2? 4. So the fourth number, and then take the fifth number, add them, and divide by 2. Here? Or higher? Look at the previous example. Well, what numbers came out? What numbers we used? We used the third and the fourth. What's 6 divided by 2? 3. So it's the third, and then just add 1/4, add them, and divide by 2. So that's how you do with evens. You have an even amount of numbers, you go, okay, let's practice. So if I want to find the median, if I want to find the median, for 50 numbers, what would be the middle two? 50 divided by 2 is 25. So it's the 25th and 26 are the two middle numbers. Add those two. Add those numbers, whatever they might be, and divide by 2. So if I have 34 numbers, is 34 an even number or an odd number? Even. Remember, if a number, if it's one place and then either the digit 0, 2, 4, 6, or 8, it's even. However, if in the ones place, the digit is 1, 3, 5, 7, or 9, it would be odd. So this one's clearly an even. So we take 34 and divide that by 2. So that's going to be 17. So 17th and the 18th would be the middle two. Add them, add these numbers, whatever they might be, and divide by 2. Do not add, obviously in this case, we don't have the numbers, but you wouldn't take 17 plus 18 unless those were the numbers. You don't take 17 plus 18 divide by 2. You take whatever the 17th number is, whatever the 18th number is, add those and divide by 2. Remember to use your calculator properly. Yeah, be careful. So any questions or concerns? Look how far we gotten down here in the notes here. Questions or concerns? Okay, I need to talk about a few more things about the median and the mode before we proceed to, the mean and median. Any questions, guys? Or this is pretty good? Are you good with it? Okay. So, the mean and median are useful but sometimes you may prefer one over the other. I'll show you what I mean. Most of you here are 15 or 16 years old, right? Some of you are 17. Who's 18 already? All right, so we have a senior. Guess what? I'm 40. So let's say in this classroom, we have a 15-year-old, another 15-year-old, another 15-year-old, a 16-year-old, another 16, another 16, another 16, another 17, 17, and we have senior over there. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers. Let's just make this easy for ourselves. We have a 14-year-old in the class. We have 11 numbers. 11 plus 1 divided by 2. So the sixth number here, 1, 2, 3, 4, 5, 6. This person here, well, that number there, that is going to be the median. Notice that we have 1, 2, 3, 4, 5 numbers here. And 1, 2, 3, 4, 5 numbers there. Splits the data in half. But let's go ahead and calculate the mean here. Let's use big N for this. This is a population. We're going to just say it's a population of this particular class. We're restricted to. So the mean here will equal to the sum of all those numbers divided by N. You already know N is 11. Now, you could do this quicker if you realize that, I mean, you can just type in all the numbers. But this is basically 14 plus 15 times 3 plus 16 times 4 plus 17 times 2 plus 18. And maybe I can make it look pretty. I mean, I can try. I can use a ruler too. So that's going to be 14 plus 45 plus 64 plus 34 plus 18. Do I use the ruler again? Yeah, why not? Divide that by 11. And so now we have 14 plus 45 plus 64 plus 34 plus 18. Divide that by 11, Control, Enter. It's going to be, I'm going to go ahead and round it to one decimal place, 15.9. So that is our mean. So our mean here for this data set is 15.9. For all purposes is 16. And our median is 16. Let's do a quick dot plot of this data. $14, 15, 16, 17, 18. This is one dot, 3 dots, 4 dots, 2 dots, 1 dot. So the data is nearly symmetrical. Okay. But now let's go ahead and take a look at this and just let's assume I mean, I'm 40. I'm in no means the youngest teacher in school, but I'm not the oldest. But let's say you have one of the older teachers in school as your teacher. I don't know, somebody here like around 60, 60 something in the school. I don't know, but let's pretend I was 65. So how many numbers do we have now? What's n here going to equal to? N is going to equal to 12. So we have 12 numbers. Should maybe write it somewhere else where it doesn't confuse anybody. What's 12 divided by 2? 6. 1, 2, 3, 4, 5, 6. So this is the first middle number. The next one will be the next middle number. We're going to add those and divide by 2, right? Notice that this will split the data into two halves. There are 6 numbers on the left and 6 numbers on the right. So our median here will be 16 plus 16 divided by 2, 32 divided by 2, which is 16. But now let's find our mean. Our mean is effectively going to be, oh, and just to let you know that this number here added up to 175. So our mean is going to be this. Take all these numbers, add up all of them, which came up to 175, but we added 65 to it, divided by 12. So what's 175 plus 65 divided by 12? Now our mean age has gone up to 20. Remember, the 175 would have been what would have been 14 plus 15 plus 15 plus 15 plus 16, all the way to 18, which we did previously up here, where I just didn't write it, plus the new 65. That would have been, again, I shouldn't take shortcuts, but this adds up to 240 divided by 20. This comes out to 20. So now in this case, for this data set, the mean is 20 and the median is 16. As you saw, the median didn't change. The median is not affected by that big number. The median is just the middle number. But the mean, because it takes into consideration all the numbers you calculated, was affected dramatically. Not so dramatically, but enough. The mean was pulled towards the bigger number. These bigger numbers are called outliers when they're really far away. I'll give you a rule later on, maybe next section, on how to calculate it, but that's essentially it. Every time you have an outlier, that happens with the mean. The mean is not so effective. Why is this important? Because we come back to the idea that sometimes we want to use the mean, sometimes we want to use the median. If the data is nice and symmetrical, nice and even, we can choose either one. However, when the data has a lot of skew, we call it, and I'll introduce that to you later in another section. When there's outliers, when there's some bigger numbers there, we may want to use the median instead of the mean, but it depends what agenda we have. For instance, most of you here live in the immediate area. This immediate area around here, the median income is lower than the mean income. As you know, in Hialeah Gardens, there's a Hialeah Gardens Estates, and we can assume that the few people that live there, their income is vastly higher than the people who live in the dungeons over here. Agreed? But if we take the median, it's not affected by those people over there that have a lot of money. But if we take the mean, their numbers will skew the average up. Because if you have a bunch of people making $40,000, $50,000, $60,000, $70,000, most of them 1,000, 2,000, 3,000 people, but then you have like, I don't know, 50 families making above $1 million. When you do the mean, those numbers really affect the average. It moves it up, the mean. But the median is not moving. As you saw from that example, the higher age didn't move the median at all. We say the median is resistant to these outliers. So if I'm trying to get money for the school, I'm never going to quote the mean for Hialeah Gardens families. I will never do that. I will never quote the mean annual income for families in Highland Gardens. I will quote the median, because the median in that case will be a better reflector of the middle, because it's not being pulled so much by the outlier. Does that make sense? The bulk of the people living in Highland Gardens have an income, a lower middle class income. There's a few of them that make more, right? And we envy these people, correct? All right, so I think I covered the main thing I wanted to cover for mean and median. Are there any questions? I know this is boring. I'm recording a video, but I'm doing it because I want to post it online. And so you're the guinea pig class of the day. Fair enough? All right. And this computer is like on fire. Like I can hear the fan spinning, like it doesn't like doing this. And so I'm assuming that the microphone's gonna hear the fan in the background. That would suck, but it is what it is. Okay. So let me make another line where talk about, hey, do my notes look organized? Bro, that's cool, right? Bro, are any of the teachers doing this? Bro, am I cool? And nobody answers the question. All right. So let's go with mode. So the mode is not too useless, but the mode is basically the number that repeats most often. Okay. Let's look at this. Here's a set of numbers, 1, 2, and 3. What's the number that repeats most often there? They all repeat the same amount of time. So we say no mode. What about now? What's the mode? 3. This is the mode. If you did a quick dot plot of it, this is a peak. The highest point is 3. Well, what about now? What's the mode? 2 and 3. Because now we would have two peaks. Now they're right next to each other, but whatever. Now, what about now? How many modes do I have? No mode. Because we have no peaks now. There's no peaks. They're all same level. No mode. Do we get it? Let's see if you get it. One, 1, 2, 2, 3, 3. Do we have a mode? How about now? How about now? How about now? What's the mode? Still 3. How about now? Still 3. How about now? How about now? 3 and 4. How about now? 4. Are we clear on how to do the mode? You can have multiple modes. If you have three numbers, let's say you have 100 numbers, three of them are tied for first place in terms of frequency, in terms of how many times they repeat, then you have three modes. If none of them, if all of them tie for first place in terms of frequency, then you have no mode. What you're looking for in the modes are the peaks of your data. The peak, the highest. You can have 2 points. You can have mountains. That looks like Batman. So there. All right, doesn't matter. Ignore the bottom part. So I guess this peak is taller. You know, if the peaks were even, if they're even, then you have 2 peaks and you have 2 modes. Fair enough? So I guess, remember, the mean, the median, and the mode are, we want to say they're measure of central tendencies. The ones we use most often are the mean and the median. The mean takes into account all the numbers, while the median does not, just takes into account, it really takes into account just how many numbers you have, and let's find the middle. So it doesn't, it's a positional thing with it. Okay? And in certain cases, we have to be careful which one we use. So if somebody says the average, you ask them which one did you use? Did you use the mean or the median? And the reason we do this is because we know that the mean is affected by very large numbers, or numbers that are really far away from the bulk of the data. All right, and we'll be talking soon about when this happens, like this. We'll be talking about skews of data, and we'll be maybe giving a rule on how to do it. So let me go ahead and stop this share. I'm gonna go ahead and stop the video once I see where the video button is, because I don't see it. Oh my gosh, okay. So, oh, there it is. It's right in front of my face. Stop video. And I'm gonna end the Zoom.